Hello, good afternoon, or morning, or good night, or good evening. I don't know. So as usual, welcome, and please let me know if the audio is fine so we can start soon. I'll just wait for the confirmation of audio is good. So thanks, Field Marshal, and hey, what is welcome. So okay, so let's go straight to the point here. Let me see. So we'll go back to the real racing game today. I have the project open here. I was testing a few things. So let me show what I already have, which is not much. Oh, I have to turn these things off here. Just a second. Stop talking. Um, oh, wait. Pause notifications. Okay, done. Let's miss this for now. So I'll bake lights soon, but let's try this first here. So let me keep the chat open so I see what you guys do. Oh, I'm still showing myself instead of the screen. Let's fix that. Other side. This is better. So yeah, get this around here, this around here. So this one. Yeah, okay, good. So let's first test it here again, and I'll show what we did new. And so it's the same as before, but I already added a few things. Like, so I do have the checkpoints, and I do have this cursor showing where the next checkpoint is, and it does update when we cross the right checksum. Okay, good. Yeah, so this is done. I'm gonna explain how this was done, but I actually left a lot of stuff to do live today. So from what is listed on the topics for today, we're gonna do most of it live. So I just added some basic plumbing already, so we don't have to waste a lot of time with positioning these checkpoints and all that. So but here's the idea for today. So the idea is that we will kind of start doing the racing controls for something like that. So we have a track, and so we had the track already from the previous one, and what we have now is we have a series of these checkpoints. And here's what we can use checkpoints for. So sometimes you see in games where checkpoints are something very very apparent, which is you cross the checkpoint, and that's kind of like a save point in these arcade style races that if you go off-road, you can reset from checkpoint to a... But even when you don't see checkpoints are normally the way to implement a lot of stuff in racing games, which is basically you need to know where the cars are related to the track. And of course, perhaps you can have a spline, and you know how far you are from a certain spline, but checkpoints are a very good way for you to differentiate if you are... Maybe even if you're close to this spline in a different place, you need to know that you have to be in a certain part of the track and not necessarily cutting corners and going to another part of the track. So that's why you have to... Normally, we rely on checkpoints to get things in sequence. So even if they are invisible, the point is that if the car passes the right directions, if the car goes through the right part of the track, it doesn't go off track, it doesn't go wrong way, it would be able to pass through these checkpoints in sequence. And then knowing in which checkpoint you are, and you ignore a check if you pass through a checkpoint that is not the next one you expect. So essentially you can have a lot of things. So you guys saw that I'm now positioning the cursor showing where should be the direction we should go to, because that's basically the direction of the next checkpoint. But one thing we could do, for example, you could hide that that cursor and only show it if the direction we're moving towards is basically opposite to the right one. So basically we show it only if it's the wrong way. We don't have to be so intrusive as to show that all the time, especially when the track is kind of obvious, like in this case here. But implicitly you always will have these checkpoints. So it's also a good way to count, to know where we are, how far we are into a lap, because this is going to help us compute who is currently dynamically, who is first, who is second, who is third, and so on, because essentially it's whoever is further down into the track in terms of laps and in amount of checkpoints crossed already into the current lap. So it's pretty obvious to do once you start. So the basic plumbing is to get these checkpoints in. So the way I decided to do this is I created a Nectar class for checksum. And I added 2 other Unreal C++ types to organize the whole thing. So the checkpoint is an actor. And this checkpoint actor we'll also have a quantum transform, meaning that we know exactly its position with fixed point numbers and all that. So it is a deterministic actor. It's part of the quantum simulation. It's kind of overkill to do it this way, but it's still it's performant enough to do it. So we don't need a lot of these. I could have done with baked static data, but I decided to just have them as these actors in the game scene for now. And so they have the quantum transform data, which means we can trust that the positions and everything are deterministic. But the way I decided to do this is, although I do have a collider in them, I'm not actually using them and their triggers. I'm not at the moment using detecting when the car passes through it with the physics, although I could. But I think I decided to do a distance check. I'll explain why. So first is because if you know exactly what is your expected next checkpoint, a distance check is much cheaper than actually expecting these colliders to do. So I could actually remove these colliders and they would still work. So that's why I went for a distance check. And the point is that we have all these checkpoints here, and we have these other 2 types I'm going to talk about. So I have a ARaceManager, which upon initialization, it grabs all the checkpoints and it creates this list, this array of all the possible checkpoints, and it knows which one is the first, which one is whatever. So it organizes this data structure in itself that allows every car that's spawned to start pointing to the right checkpoint, and then it knows which direction to go. And if you pass through it, we confirm, okay, I've done with this checkpoint, and then I can check what is the next checkpoint and do so on and so forth. So this ARaceManager type is the key for that. And then each vehicle, each car, will have this other component called on the vehicle itself that knows what is the next checkpoint, and it checks for distance. So let's take a look at the code so we understand that. But okay, so before we look into the code, so we have all the checkpoints around the track here. So let's see if I can make them more visible by doing this way. So first checkpoint is at close to the start. Then we have at the end of the jump here, we have the second, the third one here, so we don't miss the curve. Then the next one does not, we don't need a lot of intermediate ones here. I just did that one there, fifth, sixth, and so on. So I was very economical. You can make this with more checkpoints. It doesn't change performance or anything. It should be fine. But this is for checkpoints. Then the other things are, I have this ARaceManager, which is the ARaceManager is an Unreal actor component that is also a quantum object, and use this guy to get initialized with the list of checkpoints here. And you will also know which one is the start and which one is the finish. This is part of the actor for the checkpoint. We will check that. And then on the vehicles, if we look at the take a look at this guy. So if you add to a vehicle blueprint like this one here, so if you add to the blueprint this component called Quantum Vehicle Race Component, it would be aware of checksums and it would count, and this is the guy we're going to use to count laps, count lap times, and so on. So this is what we're going to work a lot on today. So let's take a look at the code of these three guys then, and that would make most of what we're going to do today. So vehicle race component, and I think everything is on this same file here for simplicity. So as I said, we have the race checkpoint. I decided to make the race checkpoint an real actor. So it is a quantum actor, just lazily inheriting the deterministic actor. As I said before, it could be a normal real actor inheriting just the interface, but I did it like this. And it doesn't actually store any rollbackable data in itself on the checkpoints. The only thing is that it has deterministic data in their transform. And as I said, we have a collider, although we technically don't need this collider. I could remove it. So this is for the checkpoint. That's basically it. It's basically to mark a position, and it has some static data about saying this checkpoint is the finish line or the start line. So the start line is the first one that will be the first checkpoint that the car should go towards, and the finish line it's the one that when you cross it, you count laps essentially. Then, as I said, we have the race manager, which will store. This does not need to be rollbackable data. It gets initialized with an array of the checkpoints. It finds these in the scene, as I said, and it does have. It's a quantum component, but this one does. It will store a few other things. So I'm doing. I haven't done this yet, but we'll need a state machine for the race, something like. So we'll need to know that we'll have a countdown when we start to run the game and everybody's position. So we will have a countdown for. Of course, technically we could have a warm up, which is even before the countdown, making sure everybody joins and everybody is in the game, and then. But let's assume. But this is a simple tutorial, so. We're going to assume that we'll join the game, and then we'll have a few seconds of countdown, and then the race starts right away. So then we'll be racing, and then when people cross the line, we'll have race is fully finished state, at which point we basically can disable controls. But of course, each car, if the car finished the race itself, it would know. So we will have to store perhaps in this guy here, the number of laps that are expected. But of course, the laps are going to be done on each one of the cars. But this is stuff that we'll add over time. But the point for now is that we do have actual game state that is mutable. And every time you have mutable stuff that affects gameplay, it must be rollbackable and data that you replicate for a late joiner. So the state and the time into each state is in here. Then last, we have the vehicle component that goes into the cars. And this guy basically is currently tracking what is the index of the checkpoint, which is your next checkpoint. So you start with the index of who is the start checkpoint. As you pass that, you get to the next and next and next and so on and so forth. So we're not tracking anything else here, but we'll soon. We can start coding stuff here. So let me add one more thing to track. I don't need to initialize this thing with a special value. I want to have something like fixed, and because it's a rollbackable data. So I'll do this. So this is current lap time. So once race starts, I will basically keep incrementing this with delta time. So I'll always know what is my lap time. And I can also have a U property for, so I can have, so I have blueprint read write on this one. So this is a nice one too. So we can have, because we already have the current lap time. So this is going to be for the actual rollbackable game state, so that we'll track with Quantum. But I'll add to that we will show on UI, and these I could use a float number for this and format that as oh, one more thing here. Let's also replicate an int for laps, completed laps. Maybe just laps. And I'll have a float here for current lap time. So I have a fixed version, but this is the rollbackable game state. I want to have one way to access this from Blueprint, so I'm going to have a copy of this that after all the prediction rollbacks that change, there's several copies of this thing here. I'll get the final version after the last one, and I'll use that to update the one that we can see on Blueprints. And it's also good that I could store, I could accumulate all my lap times either on the game state or somewhere else, but I will for now just I'll just store the last one so we can put on the UI and we know how the last one was. I don't need to store all of them. Perhaps I should later, but let's start with this. So we have current lap time and last lap time. So let me take a look at one thing here which is interesting. So far it should still be compiling because it should be building fine because I didn't change anything crazy here, but I want to replace something here. So first let me show how the checkpoint stuff is working. So the race checkpoint itself has some default components, but it doesn't do anything. It doesn't have any logic. As I said, the race manager component searches for all the checkpoints and adds them to that static list. It just initializes the references to the checkpoints. That's basically what it does here. I do this as the moment the scene, the map loads with those actors, it will initialize all this. Doesn't have to wait for when Quantum start. This can be pre-initialized. Then the whole logic is actually in the vehicle race component for each one of the cars, because eventually this guy's gonna have some logic for the state machines and all that, but I'm not doing that yet. I'll focus on what we can do on a single from the vehicle itself for now. So so the vehicle checks for, grabs from the map the reference to the race manager. The race manager is just a single ref that, again, it doesn't have to be rollbackable, it doesn't have to know anything else. Yeah, it also grabs a reference to its own transform. So notice that the vehicle component is part of the vehicle actor, so we get the owner actor, cast that to Quantum Vehicle. It expects this to be the case. I should have a null check here in this case and not give this reference if it's not the case, but this is, there are other ways to grab this component from the owner, but I just did it this way because it's hard-coded to be only working on these vehicles. So I'm just getting the pointer to my Quantum transform, which is a sibling component, let's say. And so here's the important part. So we initialize, when Quantum is initialized, I grab in my mutable queue state that the current checkpoint index is the one that the race manager tells me to use, which is basically the pointer to the start first checkpoint and its baked index, which was baked, so the index is baked here in sequence for all the checkpoints. Then here's the main part of the logic. I just get, okay, so what is the different in position from where I am and the next checkpoint, and I check the distance. I'm just using a fixed distance here. I'm going to configure this per checkpoint later. So I do just a very, very quick distance check here. If I pass through if I'm close enough to the checkpoint, I basically circle around and get the next checkpoint. So you can have, so you could have a more complex thing that has multiple different ways of going through a track with some shortcuts that give you an option of 2 possible checkpoints that you would have to know which one you took afterwards. But in this case, we only have a single possibility every time, so it is basically this here. And this is something I want to change. So, and it's actually as a to-do here, and it's a good point because we're going to compute the lap time also based on this here. So another thing we can do with the car itself is no matter in which checkpoint we are into the lap, we could be, so no matter which checkpoint we are here, we can always increment the time of our current lap. So I can always do QState current lap time plus equals, then we have tick info dot delta time. So this is the delta time in fixed point numbers, which is part of the parameter that you receive here. So this is going to be our current lap time. And one thing, so this is a tick info verified, and this is, so I'm doing this only on verified frames, which is a good point. So I'm going to do a few extra checks here. So for example, if so let's do this here. So if what is the checkpoint? This is the current checkpoint. Oh yeah, I didn't change current checkpoint yet. So if the current checkpoint finish, if this is the finish line, I can increment my lap. I can increment my completed laps. I think this is not implemented right now. It is. So I can increment my lap by 1, and I can reset my current lap time. But I also want to make sure that when I do this, so when I do this, I store it for the previous to use on the view. For the view, I want to make sure. So I'll make copy previous final lap time to view. So when we cross the line, I'll copy that on the last lap time. I'll copy this as this thing here. I think I have to convert this to a float. So how do I do? I forgot how I do. I think it has a converting, yes, floats. So this is view only, but this has to be done here because this is the only moment I know this, otherwise I can lose this value. But this one here, and I'll do one more, which is, so this one is used for the cursor. So basically I check, I do the I convert the direction from the vehicle currently to the next checkpoint to a normal Unreal F vector, and that's what I used for the cursor, showing where to go next. So I can also do here the current lap time as a float, I can copy this to be this guy. Actually, I should do this before checking and flipping it. So I can do this as float, but these three things here. So this is the interesting thing I want to change now. We're doing this even on so we are doing this on prediction, which is fine. We want to make sure that we have, even with our prediction, everything is smooth, but we're doing this for every tick, and when we resimulate, roll back and resimulate, we're computing these things every time. And although this is very cheap, point is that we don't need to. So we can just use always the last value we had after all predictions and use that one as the values for these. For this stuff here, it is fine to do here because this only happens on a verified frame, which only happen one at a time. So if we're running the game at 60 Hz, it will actually only happen at 60 frames per second. It will not, verified frames are not prediction frames, so they run at the fixed frame rate, fixed update rate. So this is not gonna duplicate calls at all, and it's the right moment to restore this or cache the previous lap times for UI purposes, but this is still just for UI purposes here. But these here, really, they're being done every predicted tick as well, which is constantly doing stuff. So we don't need to have it here. So I think I'm gonna use a different callback, because there is a callback that you get from here that I can use instead, which is called update view. I have a version with the alpha between two predicted ticks, but I don't need that. I would just use the normal update view. So I can use this guy to move my is that a protected or a public one? I forgot about that. It's the same in here. No. Oh, sorry. So I forgot. It is public then. So let's move it. So this goes together with our begin play here. And we'll get it implemented here at the end. It's from the vehicle race component. So the good thing about update view is that it's called only once. What did I? Okay, it's right. So we can actually move all these three to here. Okay, so the direction has to be recomputed in this case. So it's kind of a mixed bag in this case here. So I do have to recompute the direction in this case, but which you may say, oh, maybe this is a bit expensive, but considering that you are resimulating a law and you do a lot of stuff on views, it's always important to do some of these view-only computations on these callbacks. I will explain what is the cardinality here that explains why this is important. So this call here is called on prediction and rollbacks all the time. So for objects that are in your prediction area, this is called all the time. When it's a verified frame, it's called on everyone. But this stuff on the view does not matter how many predictions and rollbacks you're doing. This is called only once per Unreal update. Only once per Unreal update. So you get a very, let's say, a predictable load on these. So that's why I recommend doing view stuff from one of these single things. So you can, for example, also create a blueprint callable function that grabs the data you need from the quantum state, because and call it from the context of a blueprint visual update, it's fine. It will be called only at the frequency you call them from blueprints. You don't have to put that kind of visual stuff into the rollbackable main ticker here. So let make sure that this is still compiling fine, and then we'll proceed to do a UI to show this, and we'll just use Blueprint to update that. So now let's brace ourselves to make sure I still remember how to do all that with blueprints. Okay, so this shall all be running fine. One cool thing about this here is that we can always check the car here, and I don't think it's not edit anywhere, so it's only blueprint accessible. So it's actually not showing the. So it's not showing the lap time in there. Perhaps I should do that instead, because that would be an easier way for us to see the values. Let's do that instead. So I forgot to do it. So we can also do edit anywhere. So not checkpoint direction, but for current lap time and last lap time. So we can always see that. And of course so this should be before we add a UI, we can take a look at how these values are, just to make sure they are being computed correctly. Just come on. Okay, so let me make sure I get this guy and this guy. Okay, here it is. So current lap time 10 seconds and last lap time. Let's see if I can complete a lap with this intrusive thing in here. I can perhaps click somewhere else, so just so I can try to complete the lap, and then we see the values. Well, we shall do a blueprint, because I want to make sure we do it with some visual formatting. So we shall have completed the lap already. So let me take a look now. So if we look at here, so yeah, we did complete a lap in 36 seconds, and current lap times is still counting. So it seems like everything is working. Let's try to do a proper menu for this. So first thing I want to do is I think there is the car UI that I also want to. Oh, this is classes content. Where's my I think there is a okay vehicle telemetry thing. So I wanna make this. We don't need to see this all the time. So let me try visible. So we can try to do that, and let me see if that's enough. Yeah, so that's out of the way. So we can put our UI somewhere in there. That's good. So let me remember here. I'm gonna take a look at how I did the normal UI. So this is a new widget that I get these things in, and I think I need some bindings. So the binding for this one is I think it has a binding. I think that's the way I do it. Oh, it's basically a variable. Oh, yeah, it has to be a variable, of course. And then I have... Oh, this is the tooltip. I thought it had a binding. Return value tick. And that's the guy I am setting. So I get the stats from that. Yeah, and then I have a bind with this somewhere. Okay, let's build one. I'll check. So let me remember here. So this is widget blueprints. Use a widget, and this is gonna be called Arrace Vehicle Race UI. And we will so canvas panel, and then something like this. Well, how big is this grid here? No. Okay, 2 text blocks. So this one's is lab label, and the text on it, lab label. And where's the text content? Lab. And this guy, which I make, why isn't this guy? Can I make this guy larger? No, it's here. Row, column, column span. Can I make this guy pretty big? Well, this guy is gonna be in any way, this is gonna be the lap value, and the current value of it would be something like 0, 0, 0. But I wanna make this guy pretty large and align it to the right. How do I do that? So, of course I can have some padding left, but that's not what I mean here. That doesn't help. Hello, let me take a look at the question here. So the performance of the quantum physics engine is an very good question. So, but let me try to give some perspective here. First, the answer is the performance is really, really good, but you should consider it even better when you put something into account. It is a physics engine that is capable of doing predict rollback, which the physics engines you are talking about are not designed for. So PhysX from Unity just crawls to a halt if you start to reset rigid bodies trying to do predict rollback with it. It just does not scale, does not work. Chaos is also a very good physics engine, but it's not designed for this. It's not designed for rolling back. They're actually trying to do some things in that direction. I'm very curious to see how well they do, but it's not only not designed for that in principle, but it is also not deterministic, meaning that it's not useful for what we're doing here. So what we're doing here is we're doing deterministic predict rollback in that we don't have to synchronize states of objects. It doesn't matter how many objects you have. The only thing we synchronize is input. And the state is kept in sync on verified frames, and the local prediction is also very good and very performant. So we've been doing this for 7-8 years now in different contexts, like in C#, and we moved to the physics engine to C++ recently, and Unreal uses, of course, the C++ version of it. But in hindsight, the performance forward only is comparable to these engines, with a few cases in which, of course, these are better. So you can't compare. It's a stateless physics engine, so of course you can expect much better stacking capabilities and stability of stacking on a forward-only physics engine than this engine. But in terms of predict rollback, the point is it is so performant that it can do that, which is what these other physics engines cannot do at all. So that's the first thing. And even considering the verified frames only, the performance is comparable, sometimes even better than these as well. So it is a trade-off, right? So when you go for an engine like Quantum, is because you were doing super local-like physics interactions, and that's where this type of physics engine shines, because it does that so well. And this is what I expect you guys will see when we playtest. I expect to create a build for a playtest, not on this stream, but on the next stream. I expect to have something that we can actually playtest. So, damn, I'm not gonna I'm not gonna waste too much time here, because I should have prepared better for this. Sorry. I'll add enough space here that we can. I'll make enough space here that we can have what we want. So that's the last lap label, and let's use the last label. So this is just for us to position it here, and then we're gonna duplicate this one as well here down, and this goes in here, and this is gonna be called last value. Hopefully I'm not gonna take too long to understand all this. So let's kind of try to keep it short here. Perhaps I should make this much bigger. So can I, where is my font size? Okay, I have our Roboto. Let's double the size of this. Something, yeah, much better. And let's use well, if I put an orange color, it's going to be very difficult to see. The world is very bright, right? So perhaps I can do something like this, and it will stand out against it. Let's see. Okay, let's try to do something like that, and that should be. So first I want to test this. So we have this widget here. Let's get our car again, and I want to spawn this. So I want to spawn this only for the local car. So it has to be similar to what we're doing with the create vehicle telemetry widget, which is this here. Yeah, I can do another one, which is create widgets. Yeah, create widgets, and then it can be vehicle race UI. So we create this guy. Then, yeah. So we can get this guy and add to viewport. Add to viewport. So doing the same as the other one. So the other one is invisible. So this is enough to show it. Are we doing this only for the local player? I guess we are. Yeah, it's local player. So this is only done if we are the local player. That's good. So we only care about creating this widget if we're a local player. So let's see if this is positioned correctly. Okay, yeah, it's visible. Let's take a look at the visibility of this blue thing. I think it's looking okay. It's easy enough to see. Perhaps I should use different colors on the different ones. Yeah, it's overall very visible under the light and colors we have in this map. Yeah, okay, good. Now the challenging part, which is what I don't remember. So how do I do the vehicle telemetry? That's a good idea to check. So where's my... So this, oh, this is the... I should actually look at the vehicle. So I set what? Oh, okay. How do I do this here? Let me try to remember how I did it. So I'm pretty sure it's not here. Stats. Ah, okay. I get it now. Because I added this stats thing. So I created this stats thing, and from the stats I grabbed okay. Yeah, that's it. Okay. So this guy, it has a variable called vehicle that it gets set. Yeah. And then I read from there and I do it on the bind. Yeah, that's it. So that's it here. Oh, this is... I love this knot. I wish, so if you guys have any suggestion of a nice UI tutorial for Unreal that does not end up like something like this, like a crazy blueprint like that. So look at that, right? So the point is that, I mean, it can be my fault, right? So I'm a C-like programmer, and I like to do stuff in C, C++, C, C Sharp. But when I search for UI tutorials in Unreal, I always only see things done in blueprints, and when I apply the techniques I see there, I always end up with something like that. So I would love a suggestion for a tutorial for UI that is targeted at, let's say, traditional C-like programmers on Unreal. that would give me a nice and tidier result in the end. But I just need something quick here so we can get our widgets correct here. So let me get my UI vehicle race UI thing here. Let's try to add the variables we need here. So let's add one, and this is gonna be of type. We need quantum vehicle race component. Yes, so this will be my vehicle race. This is so this is the it will be a reference to the the actor component of the quantum vehicle race type. So if we go here, when we spawn this guy, we can use set. No, actually, we get this add to viewport. So I can actually get the same guy here, and I can do set vehicle race, and this vehicle race can be this guy here, this. So then at the end here, so linking stuff is complete in that our widget, once spawned, will have a reference to our component that from our code here has current lap time and lap time as float numbers. So we can use that to show on the UI. Let's go back here. So now we need to do this. How did I do that? So I need to bind this so I can update its value. So is it end? Come on. Oh, I need to make this a variable. That's one thing. So this guy must be a variable. This one also must be a variable. So these two being a variable can get here in the graph. Yeah. Oh, nice. So event take. So what can I do with this guy? No, I cannot just get lap value. Set text. Can I set the text here? Looks like. So if I just get event tick to set the text, and the text is gonna be my vehicle race, and I have the variable called current lap time. This is a float. Can I just convert this guy? Maybe that's it. I don't need any binding. Roundy mode, have from 0, maximum integral digits 2, minimum fractional digits 2, maximum fractional 2. I like this thing. So it formats it for us. Good. Nice. So let's do one more. Just set text on the lap value, and the last one, oops, and how do I do this? So the last one, set text. This is gonna grab a last lap time. We put this guy in here, this goes in here, and we use the same, use the same maximum here, integral digits 2, 2, 2. So I think this is nice. Let's see. Is that it? Is that complete? It was easier than I thought. Yeah, it is. Great. Nice. Cool. Nice. So we have 15 seconds. Come on. Oh, we finished at 17. Let's see if I can make this one faster. Okay. Okay, still going. Now 16. Yeah. Okay, good. We got it working. Great. It was not that difficult. It was nice. Okay, cool. Hi, Ruben. Okay, that was easier than I thought. So we got our lap times, and we also have our lap counter. So let's add that. It was so easy that I thought somehow we could perhaps. So which one should be blue? Let's make the current one white. Whiter. And let's, oh, I shouldn't call this one here last. Also, kind of something like that. So lap, last, time. I'll call this time, last. Let's duplicate this thing. I'll call this time label. Time label. This one's gonna be called time value, just to keep things tidy. So this is gonna be the laps label, and it will go here, and we'll have another one. Oh, not that. So duplicate this. This is going to be the laps value. This is already a variable. It will go in here, and we'll use a different color for these. Something like this. Hopefully it's going to be visible. And we'll call this laps. And we'll start with 0. And but we need the counter, the UI version of the laps for this to work. And here's the interesting thing. We have to expose that to blueprints. So one curious fact here for you guys who are following the evolution of this whole API. So when we have these QReplicate variables, or even if they are blueprint editable, at least as initial value as prototypes like we saw before, there is currently this limitation in that we have not yet automatically exposed this to blueprints, because we could make the Q state itself, which is this code-generated pointer to an abstract. Perhaps we can make that a U property that's accessible to blueprints, but it is important that can be used as read-only, perhaps in blueprints. But we haven't experimented with that yet. We plan to do. But because we have not done that yet, we don't have direct access to the Q state because it's a pointer. We're not exposing that directly to blueprints yet. Normally, I'm doing these copies, and most of the time doing these copies for view only is important when you want to have a value that is of a type like a float. But we have an interesting case here in which laps is an integer. So we don't need to convert to a type that blueprints know how to put on a widget or something like that. So, and even FP, we have the conversion method, so we've done in a few experiments to convert to use FPs directly in blueprints as well. But we're not exposing the rollbackable state directly to blueprints yet. So we have to create these things. And one way of it's having this copy of something. But what I'm going to do here is I'm going to use a function instead. So I'll just use another example because I do have a blueprint callable function in other examples here. So I can create a public blueprint callable function. And I'll call this function is going to be int get laps. And the implementation of this function will basically be if qState equals null ptr, we return 0. Otherwise, we return qState laps. So we don't get into any null pointers before the game is initialized. When the game initializes, it starts to get the right value. It's a trade-off between using a copy or accessing directly here. But if you access directly, even when we do expose this, there is a chance it would be null, specifically when the object is spawned and it has not yet been initialized. So in this particular object, because we're spawning it dynamically, first time a blueprint update for the view is called, it will already be initialized. But if you add these things to the scene, before quantum starts, the quantum state is null. So it's a bit more challenging. So I tend to like more the copy for the view variable. But yeah, it becomes it's a trade-off. So, okay, so we can now do the same thing here for the, so we got the time value, we got the last value, and we can now get the lapse value. And we can set text, and the set text of it that will come here will be get lapse, which is a blueprint callable function. Oh, the problem with this is that I have to call this and then get this in here. So let me see if this integer has minimal integral. Yeah, 1 is fine. We could force it to be 0, 1 all the time. So I think this here should work. Yeah, it does. So let's see. So I have 0 laps, no issues with nulls. Let's finish a lap. Let's see how fast I can do it now. I am tracking a bug here that we recently found what it is. So this is an early access version of this, so it does have a few bugs. So I was investigating this particular bug that we noticed here. I promise this will be fixed by when we'll do the actual playtest, so we'll not get into this. So I think today we found the actual cause of this, and we'll get a fix soon. So 1 lap done. Let me see if I can beat this time. So 16:33. Perhaps, oh yeah, I should store our best lap, right? I should definitely store a best lap. That was the best now. Yeah, why not storing a best? I think I should store the best as part of the rollbackable game state, by the way. So we will always have, we will always store what was the best in the end. So bang, 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 bang. Oh, that was not so good as the last one. Okay. So we have laps. We have time, less time. It's straightforward to do best, right? So I will not do. You guys decide. Should I do the UI for that or not? So what should I do now? Because we do have. So let me see the topics I suggested to do today. Let me take a look here. So I showed the checkpoints, explained the URaceManager, UVehicleComponent, and actor components. We have the direction cursor, we have lap times, we don't have distance raced, and we have the basic UI blueprint. So yeah, we're pretty cool, pretty good on the, pretty on track with what we promised. So we do have time to do a few different things. So let's see here. So we have already the current lap time, so it's kind of straightforward to do this also, which is okay. Let's also store the best lap time. Best lap time. It will be initialized as 0. And what we'll do here is on our deterministic tick, when we finish a lap, that we get the next lap, and we have the current lap time here, we also compare if qstate dot best lap time. No, this has not been generated yet. So if this guy is 0, because we haven't stored any lap time, we're gonna store it. Or this guy is larger than our current lap time, which is the one that we're storing here. So in this case, we will replace the best lap time with this. And this is going to be rollbackable game state, so even for late joiners, we will always know what is the best lap time of each one of the cars, or whatever. We never lose track of this. Even if we go multiple laps, we will always have this as part of the mutable game state that we know. And I want to, because this is all easy and fine, let's get this working, but I want to take the time to explain one topic that I've never talked about before on these streams. So we'll talk about quantum events in a few minutes. Let me just make sure we complete this here. So I'll get this guy down one more. What am I doing here? Why is it? Oh, damn it. It's all correct. So let's do the last here. Let's call this guy best label. Just it's cutting the order. So best, yeah. Best. What is the row? Row 2. And this is in row 4. Yeah, it needs to be row 3. And this guy also needs to be row 3. Yeah. Now I need a copy of this guy. Below best. It will be best value. Sorry. Which is a variable. This guy goes in here. We need a new color. This will be our best. I did not create a function for it, right? Let's do it. Forgot about it. So we'll do that with a function as well. Because I'll not cache it at all. I'll just do one that converts this to a float. Um, no, you know what? Thinking here. I'll do it like this and then, because it's actually a very good example of replacing a few things that are being polled every time with events. So that was a very good idea actually. So get best lap. So we have here, so get best lap and last lap time. So they are kind of values that do not change. And I have them as a copy, I have them as a function that returns a value. So two examples of how to do this, but there is a better way to do both. I'll show in a minute. So let's first implement it like this, so we get it working on the blueprint. And then we do something very similar here. We return 0f, so best lap is not yet there, and then best lap time dot as float. Why isn't this accepting it? Okay, so last time I did this Unreal Quantum stream, there were a lot of questions, and I didn't have, I did have a very good question from Field Marshal. So guys, please ask questions. It's always rich and enjoyable when you guys ask questions, and they're ultra welcome. So if you're thinking about anything, just spill it out, ask the question, I can answer. If I can't answer, I'll just say. But I always try my best. So, okay, we have to grab the best lap now at here. So that's next. So let's get best value. Let's set text. I'm pretty sure this here is super slow way of doing it in Unreal. And but it works for now. So get best lap, that already gives me a float. So that's what I'm calling after this here. And after this, I set the text with this, with the conversion thing. And the conversion thing here, so this is lap time, right? So minimum integral. Oh, I have minimum as well. So max and minimum. I'm gonna fix the other two. So it's 2, 2, 2. So am I doing this on the other two? I don't think so. Yeah, I was not using this. This is nice because it starts with 0, 1 or 0. That's cool. I like this converter at least. So that's the kind of nice stuff when you have these visual stuff. When I drag and drop to convert from float to text, it already shows what makes sense, which is formatting. So it's nice to have. I have to admit that. It's the kind of stuff that you always have to remember when doing code. Soon this is the kind of stuff that AI will always do anyway, right? So, okay, let's see. So I'll do kind of a regular lab. Oh, we got into the bug again, so unfortunate. I can explain this bug later. So it has something to do with network loss that it's getting the transport layer into an unstable state that we can fix. We have a good idea of what it was, so it took some time for us to find, but it will be fixed, and hopefully for the next stream it will be fully fixed already, and when we do the play test, it will all be good. So, okay, so we got one lap. Oh, damn it. Let's do one more lap. Sorry. I'll try one more time. I hope to fix this soon. That's annoying. Yeah, so it's early access beta software. It has bugs. But I will we are on track to fix this, and once I do, I will confirm it is what we thought, and most important points that it will be fixed. So to get a best lap now, I'll have to actually do a, oh no, come on, this is not nice, because I'm not able to test it. Just try one more time before I move to the next topic. I will not be blocked by this. So it has to do with network loss and getting the transport layer into a bad state, and we know how to solve this. It's just that I didn't have time to get it done before the stream, because I actually found the cause very recently only. So let's see. So best, oh, I did the last and the best are the same. So I have two ways of knowing if this is right, which is I can either do a better lap or a worse lap, because then last and best are gonna be different. So no, actually I have to do a worse lap. Okay, so wow, the difference is small, but it's still not better. Okay, so this is not gonna be a good lap. So where am I now? What is is it this direction? Yeah. Okay, so this is gonna be a bad lap. So last is going to be pretty high, and our best is still going to be 1640. So let's see. Yeah, this is pretty bad, 25, but let's keep trying. Okay. I don't think I can beat that with the current. Oh, I missed the checkpoint. That cut the deal. So that was a 24-second lap. So that's one. If the thing does not break, we'll... Oh no, that's gone as a lap. So no. Okay, good. So it's all working. So I'll not talk about this. We'll fix this bug, and when we do the playtest, it will be good. I want to talk about something else. So when you're doing predict rollback stuff, one of the interesting challenges is how to update UI like this. So for now, to update the UI, I've been basically polling data, which is I have been reading the current state of the simulation and either storing it as a copy and passing that up to the UI. But I'm constantly doing that. Sometimes you want to have things like events. You want to make sure that when something happens in the game state, you want to inform the UI that happened, but you don't want to constantly poll, because constantly polling may be expensive. So you want to make sure you don't do that all the time. But when you're doing prediction and rollbacks, you have a challenge here, because you can only fully trust a result if you do it from what we call verified frames in the simulation. And you do have that. So for example, if you're talking about best lap times and last lap times, it's fine to do it on a verified frames. Just a few milliseconds after it happens, and it's good enough to get it without using prediction data. But sometimes you want to have stuff like you want to fire a audio effects when you cross the line, or when something happens. You don't want that to have 50 milliseconds delay, or another example is, a very good example is when the car jumps and you bang down back to the ground. You want to make sure that you trigger visual effects like particles and audio effects immediately. But here's the challenge, that when you're doing a single player game, this never exists. So if you decide to do this from the simulation data, only on a verified frame, it will be not instant enough. So it will not feel good. If you decide to do that by polling data, you have to kind of, okay, you have to know what was the grounded state the last time you rendered something, and what is the grounded state now. So you have to do some kind of logic to compare what is the grounded state as part of the view updates, and you may make your view updates bit complicated. So it's better to try to react to a collision callback and those things and try to do it immediately. The problem is that when you're doing this with predict rollback, these things happen multiple times. So you can have a collision callback being called multiple times. And this switch between grounded state or not will happen multiple times as you resimulate in prediction a lot of times. And you want to make sure you only call these things once. So in the C# version of Quantum, we have this concept of events. And the concept is you can call something like, you can trigger a callback to the view, to the UI or something like that. And we call these an event. And the payload of the event is used to compute a hash code, meaning that when a resimulation of the same frame happens, the code is going to call again and try to send the same callback, the same event, but the payload of the event is going to be the same because it's going to be on the same tick number with the same data because it's the same prediction as before. And because the payload is the same, we can recognize that that was already fired and we don't call the duplicate it twice. But more interesting than that is that when eventually this same frame gets verified, we can check if the event was fired again with the same payload. Because if it was eventually fired, we can say, hey, by the way, that event that we already triggered is confirmed. So we kind of give a 2 steps for an event. We fire it immediately and then we later say, we confirmed that event. And the other thing is that if it didn't happen on the verified frame, a certain hash code from the hash codes on a certain tick, if they have not been confirmed, we can call another callback saying, hey, remember that event, it's cancelled. So for example, if you fired something based on a prediction that's something that you expected to happen and it didn't happen, you can cancel the visual effect or fade out an audio, something like that, as quick as possible, but fading it. So it creates a lot of interesting possibilities if you have this capability. And the way we did this for Quantum Unreal is interesting. So essentially, you can create any Unreal F struct and use that as an event payload. And you can be creative and put the data you need on one of these. I think I have a couple of examples on the spawner. Or is it on the vehicle? I think it's on the vehicle. Yeah. I'm going to copy the example and use it on our new code. So this is suspension state, wheel state, axle state. I'm going to just copy the command. I thought I had. Is it part of the... Maybe it's on the character controller that I added an event? I forgot where I had one. But anyway, I can create any F struct type and it would work. Let me not bother. I'll grab just any example of an F struct here. It doesn't have to be a quantum one, so that's one interesting aspect of it. So I'll just copy this one as an example and I'll put it here. So it will be on our quantum vehicle race component thing. I'm going to create I'll create an event for best lap changed. So F best lap recorded. It does not need to be a quantum struct. It just needs to have ideally I should have a pointer to the car who did it. So perhaps I should UVehicle. Oh, I have to do it. No, I'm not gonna complicate it too much. Ideally, I don't want to have to do a forward declaration here. So I'll just use here time. So it's a best lap recorded with a certain time. It's only matter for the local car in this case. And what I will do is I'm going to use this as an event when a new lap happens, and I will not change the best. I will not poll the best lap. Well, yeah, I will not poll the best lap at all. So that's a good example. So I don't know how many of you are following, but this is going to be an interesting example. Okay. So first on the code here, what we're going to do is, when you have this thing about the best lap here, let me try to remember here how the API for an event is. I think it's on the, I'll just search for it here. I'm pretty sure it is part of the implementation of the interface. Okay, empty state on init. Dispatch event. It's called dispatch event. I pass in a pointer to my event and then it returns it to me. Yes. Okay. So if dispatch event, and then I can, well, I have to create my best lap recorded event equals f best lap recorded event dot time equals whatever was the best time. So we do this here. It's just a local on stack struct class object, not going into the heap. So I'm going to dispatch address of event get world. So what I'm going to do here, so I have a problem with this here, which is this is being done on verified frame, so this is kind of redundant. But I'll keep doing it this way, because this is the logic for using an event. So in this case, it's kind of already not being called in rollbacks because it's verified. So perhaps I should use another example. But I'll still avoid the polling by doing it this way. Of course, I could have just called the function directly, the function I'm going to talk about directly from here. But the point is, my point is, if this does not, perhaps I can remove this verified here. Yeah, I can. I think I'm pretty sure I can remove this verified here and do this even on prediction. Let me see, because this is rollbackable, this is rollback. Yeah, I can. Well, this is not rollbackable, but because we're actually gonna use an event for this as well, yeah. Okay, yeah, actually I can remove the verified here and demonstrate that this part here of crossing the finish line actually happens in prediction multiple times, so we can use a log, for example, but the event itself will only be called once. It never calls multiple times, because it uses the hash code of the event directly from Unreal, the memory hash code of that. It's just a local hash code, that's what matters, and we will not call this twice. So what I will do here is I'll add a blueprint implementable function. I think I have an example of one here. not blueprint callable, but the opposite. Blueprint implementable event. So I'll add that to the vehicle race component API. And I'll call best lap recorded, and I'll pass in float lap time. I'll implement this on blueprint, and this code here is gonna call best lap recorded. I think I can do it. Oh, and then I do event dot time dot as float, because I'm already converting to float here. So let me see if this all compiles, and then we'll go to blueprint and change the polling base, the stuff that we're doing all the time, to react from when this is called only once. And this is better instead of doing a thicker UI on blueprints. Even if that does not roll back, this here is even better because you will keep everything in C++. It's very efficient to do it this way. It would keep our blueprint calls a bit tidier. So let me see here. In this case, I'm not going to do on the vehicle race UI itself. What we'll do is we'll do it from the vehicle. I think I can do it from the, although it is implemented on the, it's implemented from the quantum vehicle race. So I think I can create and what is it called? It's best lap make no. Can I have the blueprint of this guy instead? That's interesting. So best no, this is the get best lap. How can I create a blueprint of the for this guy? Because I have the init UI from the actor itself. I'm not sure I can do it in here. Yeah, I'm not sure. I don't wanna have to add no. Let me see if I can very quickly search here. Blueprint graph for actor component. Blueprints. Not very lucky here. I will not waste time searching because I did not know how to do it. So I'll fix this with a hack for now, which is I'm gonna add the function. Instead of adding it here, I will do it to the vehicle itself. For now, it's kind of ugly to do it this way. I'd like to keep it in the component. I'll search if I can do a blueprint graph for that particular actor component instead. But for now, I'm gonna make this part of this interface here, and I'm gonna call it here because I do record who is my car. I'm not recording who my car is, but I'm gonna do now, which is I'm gonna keep a reference. So I do have the, this is not private for now, but I'll I'll do record reference to my vehicle. I'll call it just vehicle. And I'll initialize this guy here. So vehicle equals this. And then we can use the vehicle here. So, because then now, when I do this here, I can just call vehicle best lap recorded. Because I added it there. Let's see if this all compiles. And then I implement this on the blueprint of the car graph. And I use that to change the widget value. Instead of, oh, why didn't it compile? Oh, okay. Yeah, okay. Where? Ah, okay, on the H. I think I can do the forward declaration here. Yeah. Hopefully this is going to work now. I still have about 20 minutes. That's good. So going back here to the car now. So the car can implement that here. So what I'm going to do is I can have here event, it's called best lap recorded. So this is the interesting part. So instead of calling every tick stuff, when eventually here and there from the simulation, I call this, I call that function, then this is going to be executed. And when this happens, so I'm creating my, so I want to make this promote this guy to variable. I'm going to call it, so where is the variable? Race UI, that's the name of it. So let's do it from here, and then from here we add it to the viewport. So I'll store the race UI, because then when I have a best lap recorded, I can call this set, oh no, I can get from this guy the get best value. And I can use set text on this guy, but instead of this being done every frame, it will be done only when this is called. And then we get the lap time here, and we do the conversion just like we did in the other ones. So 2, oops, not 21, 2, 2, 2, 2. So this is going to be called much less frequently. And now we can go to the Race UI blueprint, and we can remove the best lap one, because we'll set this from the event instead, and this is more efficient. I could do the same for the last lap, but I'm doing this just as an example. So let's see if we get the first lap recorded as best now. It shall. So as long as the thing collaborates, we shall be able to do it. Bang. Done. So I'm not polling I'm not polling the data every view update anymore. This is not being updated at all, best. I'm not converting to text, I'm not doing any of that. And best is basically there. And I'll complete another lap here. It will not be a best one. So it will not be updated, it will not be even tried, anything like that. So you will not be constantly doing that anymore. So lap recorded, doesn't matter. So we could do the same for all of these things like laps, last, all these we could use this event-based approach, and you can even use in prediction, and you will never create a problem. It would always work fine. So this is normally this is the best approach for UI updates, but there is a caveat to this. So the caveat is what if you late join, right? So if you join late into the game, you should always initialize your UI from the initial snapshot value you get for the whole game state and whatever. So you should be able to initialize your UI once, but then you can rely on these events for updates later on. So this is the rule of thumb. So if you support late joining, reconnecting, you make sure to initialize your UI one time when you do this, and then you can use this approach of events to do it to keep it updated with good performance. That's the point. So you do not have to do these crazy things here that are constantly ticking the UI and reading stuff to convert. So instead of doing that, you do like we did here, which is we create a blueprint implementable thing that when we call this from C++, you will update the UI. And then one thing you can do is you can, if you receive a snapshot, you can call these events once just to make sure your UI is initialized and all that. So that's one good way of doing this, even reusing these events. So you create a function called like init UI, and from there you just call all these, and it makes sure you initialize everything correctly with the values you received. Okay, so we're getting close to finish time here, and I still have some time for questions if there are any, and if not, I'm gonna stop for now here, and on the next so because we have the lap times and all this, so let's think about if we have multiple cars. So if I already showed that this already works in multiplayer. So on the first stream, I'm not gonna test it again here, although it could. So because we have all this, we can compute positions based on what is the current checkpoint I am plus how close I am to the next checkpoint. So we can create a value out of that, like a double fixed point value out of that, and use that to see who is further into the race, and that's going to be first. And then we can store that as a distance completed kind of thing. And with this distance completed kind of data in, we can make the positions, for example, computed totally on the UI. We don't need, for example, to know who's first or not on the gameplay, but normally you would like to know on the gameplay if you're doing an arcade racer, because you might do some rubber banding for the others. I'm not going to do that. So we could use the positions just as a UI thing. So we could sort based on this distance for the UI only. But because this is kind of trivial, I'm not going to focus on that a lot. What I would do is I will show, well, I should do, because it's cool to know who is first or not. So I'll do that, but I'll do that off camera, so we don't have to waste time with code on that. But what I actually want to do live on the next stream is I will start with some basics, but I'm gonna try to implement a race AI that tries to race these cars towards the checkpoints, and doing it safe enough, and we'll discuss about these techniques a bit. Of course, it will probably be a very, very bad AI at first, but we'll see how we can improve and ideas for that, okay? So since I don't have any new questions, thanks for joining, and it's been fun, and see you guys next time then.